bodies hit the floor. Let the bodies hit the floor. Let the bodies hit the floor. Let the bodies hit the floor.
Good evening. Welcome to the STEM Shed. So, this is gonna be one of the first videos going over the science and math of COVID transmission. I'll be speaking of asymptomatic and symptomatic people. So, 2020 was a year of information overload. Experts came out of the woodwork to profess they knew what was going to happen. Worst of all, they gave solutions with no context. Solutions that sometimes did more harm than good. Data indicates, studies show, science says, which is my least favorite. I hate that. Anyways, the above statements often led newscasts and social media posts. And yes, that includes yours. I know you just think it's your grandpa that's the issue, or your boomer parents, or I guess depending on how old you are, your Gen X parents. But you're guilty too. I've seen your TikToks with the dancing nurses that point at random things in the air, or doctors. That doesn't tell you anything, but whatever, another day. If you like Chinese sponsored spyware, go for it. So, a lot of experts like to give answers without context because they assume you are too ignorant, too dumb to receive unfiltered facts. I disagree to a degree. This stuff is complex, yes, but if you truly understand it, you should be able to explain it to the average person. Now, at the time of this video, roughly 30% of U.S. adults, or of the U.S., I'm not sure actually what the CDC uses, if they're just talking about qualified people or unqualified, because there are 60 million kids who fall below the 16-year-old threshold. But either way, 30% of the U.S. is fully vaccinated, and 43% have had at least one dose. Now, more importantly, the vulnerable population, 65-plus group, is fully vaccinated at 68% and has done one dose at 82%. Which one dose sounds bad, but keep in mind that places like England or the United Kingdom are just doing one dose of Pfizer right now. My source on this, by the way, is Google and the CDC. So there you go. Now, I am fully vaccinated, yay. I'll do a video on science of vaccinations when I learn more about it. But I'm a regular chemist. I'm not a biochemist, so not really my area. But I do want to learn about it. Now, this video isn't whether about you should or should not get the vaccine. I don't care either way. Do what you want to do. But in the coming videos, I will discuss the transmission of COVID from symptomatic and asymptomatic people. So that'll be worth keeping in mind that that if you do have a shot and you become asymptomatic, and you do get it and you're asymptomatic, you're less likely to most likely less likely to transmit it. I'm not going to get any definitives yet. Now, of course, my typical warning, I am not a medical doctor, I am not an epidemiologist. My field of work is actually boring in regards to the cool research that pharmaceutical scientists are doing and university researchers do, but it pays the bills. However, it is semi-related in that I deal with fluid mechanics and surface science a lot. Two things that are necessary for COVID-19 transmission, at least in my opinion. Now, generally you're told to mask up just in case. Some places like North Carolina have mask mandates over a year later. Mask battle took place and both sides decided to be assholes about it. I'm focused on the post-vaccine era, where masks will no longer be a normal. But again, I will be discussing masks because I found some interesting information on it. But that'll be many videos down the road. But relative to what I'm talking about. So okay, let's discuss the transmission. Now, let me move my notes. Yes, I use notes. I'm not a memorizer. I write this once and then I go through them. Alright, so let's discuss the transmission. So a person without COVID, this person needs COVID, So for a person without COVID, this person, to get COVID, someone with COVID needs to pass it on. Here you go. Or not. They need to pass it on. Now, this is a respiratory virus. Now, there is some debate between whether you actually get it from touching a surface, picking your nose, or what else. But, again, I'm going to focus on respiratory. Yes, that's you. That's the light. And again, my kid here is because I do this for my own entertainment. So, and he kind of finds this fun because he likes the shed. So I don't care. I know people don't like it. But again, no one's really watching this. But anyways, for a person to get COVID, they have to transmit it. So it has to go from here, point A to point B. There's a lot of things that happen between this distance right here. So things we need to consider. Infected cells are not just floating around in the air, like inside like the actual air. That's mostly nitrogen, remember that. They are on the trachea walls, or the walls of your nose. You might remember when they did those testings in the beginning, they shoved that big old Q-tip up there and scratched your brain. So obviously you have to get up here to get enough, or at least enough infected cells. Enough infected cells for it to happen. Now, the thing to keep in mind is a lot of times it's obvious when a sick person is sick. So, again, some of the big focus comes to asymptomatic people. So, people who have no sore throat, no coughing, wheezing, runny nose, no temp. For all we know, they are COVID-free. I love you too. Now, there will be many videos over the scientific concepts. Here I'm starting with the lower respiratory. So this area down here, trachea, bronchi, lungs. So I'm starting there. Now, in a study, and by the way, this is really great time for research. Elsevier, I guess, a scientific resource, has COVID-19 Resource Center with free information on published papers. This one actually, guys, from 2020. I know. Alright, hold on, I'm going to let him down. It's from 2020. So, it actually turns out that the virus will actually will infect you here, upper respiratory and lower respiratory. So, it will infect you there. Now, one of the big things to think about is this, sorry, brain farting. Here's my lungs. Oh yeah, so to reach you, this person needs to move from here to here. So as you know, you breathe. You know, your diaphragm contracts and relaxes. So it opens the lungs, and then when it relaxes, it pushes the lungs out, expelling the air into the atmosphere. So it expels there. And with it goes the nitrogen, the oxygen, carbon dioxide, and also your cells that have the infected bacteria or have the infected virus in it. Now, for it to get out of the cells, because they are stuck, there's an adhesion aspect to it, they need to have enough shear force for it to go off. So, infected cells are not just floating around, they are on the trachea walls, which is where I'm going to start at, and they need a shear force to move them off of the walls into the air and into this person. Droplets also need to survive outside the body. You have so when the droplets are here with the little virus, the virus does not sit around by itself. It would, if you go in my earlier videos, you see it's a phospholipid, and it would just shred in UV. So it has to be in some kind of container or a cell. It has to survive the sun's radiation. It has to survive that. Now, it has to go through all these. It needs to be small enough to float so it doesn't fall down to the ground, but big enough to carry a 0.1 micrometer virus. And also the question is, are they asymptomatic? So, in the next video, I'll be discussing laminar and turbulent flow in the trachea. The speed of the sneeze will be used to discuss the Reynolds number, which is the most important number in fluid dynamics. Is turbulence good? Does the sneeze really travel at 223 miles per hour or 100 meters per second? No, it doesn't.